Okay, hello again, everybody, and welcome to today's lesson. Today's notes, we're going to hop to 10.2, part 1, and we're going to talk about how to graph a hyperbola, a basic hyperbola. In 10.1, we did ellipses, which were oval shaped. We'll talk about a basic hyperbola. We're going to keep things simple and just talk about basic hyperbolas and how to graph them. Now, a hyperbola isn't a common type of shape. It is basically two parabolas or two curves, okay? And the hyperbolas we graph in this section are either going to look two curves like such, where one is basically opening upward, the other basically opening downward, or some of them might be opening to the left or opening to the right like such. Okay, so that's basically what most basic hyperbolas look like on a graph. There are some exceptions and it could change and, be facing a different direction. But for right now here in 10.2 part 1, that's how they're going to look, okay? Notice how each of these two have what we call a vertex point for each parabola, two vertices, two main points. Same with these two vertices, two main points, okay? Now, there's some other characteristics, but we'll get to them. All right, all the ones we do today in part 1, the center is going to be at the origin 0, 0. So these are all going to be centered at the origin 0, 0. For right now in part 1 today, okay? Now here's what the generic hyperbola equation or function looks like. It's very similar to an ellipse. In fact, almost all of it is the same as an ellipse. The only difference really is instead of a plus sign, you have a minus sign. So whereas in 10.1, if you had something like this, an equation like this, but there was a plus sign, that was an ellipse, an oval. Well, if you see a minus sign, not an ellipse, rather a hyperbola, okay? Now, another thing that's going to make a difference in the equation into how the graph looks is whether your x fraction comes first, the fraction with the x squared, or whether the fraction with the y squared comes first. That makes a difference, okay? And here's how you're going to know what it's going to look like. Because remember I told you it's one of these two shapes, or one of these two images or looks. Well, if your fraction with the x squared comes first, just remember it's going to cross the x-axis. It's going to look like these. The curves are going to resemble these. All right, curves opening to the left and the right, because those two curves, remember the center's at the origin like I told you, those two curves would cross the x-axis and x comes first in the equation. All right, on the other hand, if the y comes first, it's going to resemble these two curves, which are going to cross the y-axis. And the parabolas or curves are going to open upward and downward. Okay, so that's how you tell which of the two it's going to be based on whether the x squared or y squared comes first. Now, not only are there two main points or vertices, I'll tell you how to get those in a moment, but there are also two asymptotes for these hyperbolas. Hyperbola graphs have asymptotes. And the asymptotes just resemble an x. One asymptote goes diagonally this way, and one of them goes diagonally that way. Okay? And the curves don't touch or cross the asymptotes. Same with this. Asymptote that way, asymptote that way. Center is 0, 0, origin like we mentioned. Okay? So remember we're graphing these. Each of them has two asymptotes. and two main points or vertices. Each curve has a high or low point, a vertex, okay? Now guys, there are a lot of, before we do some examples, there are a lot of different equations these asymptote dotted lines can have. They're not always perfectly diagonal, 45 degrees straight through the origin. For us right now, just draw two asymptotes that resemble an X. Okay, we're going to keep things simple for right now. We're not going to talk about how to get the actual equations of the dotted asymptote lines. We might hit that later in the year, but we're not going to do that now. So when you make your asymptotes, you're just going to put a dotted line X centered at the origin. Okay? All right, so let's try a few of these. Here we go. Number one. All right, so everything fits the generic equation. You have it equal to 1. You have the subtraction sign, so it is a hyperbola. All right, so let's go ahead and make our graph. We're going to have two asymptotes. You can go ahead if you want and just graph those. One of them diagonal, the other diagonal, resembling an X shape. Now, the X squared fraction comes first, so you're going to cross the X-axis. So the curves are going to resemble that. The way you find out what numbers it crosses at is you simply do what we did on the ellipse graphs. You take the square root of the bottom, the denominator. That's 3. So your curves are going to cross the X-axis at positive 3 and negative 3. That's where you put your 2 points or vertices. And then just simply make your curves like such. We're going to keep things simple. You need the asymptotes. You need both points where they are. All right? And that's it. Now, again, we're going to keep things simple. We're not getting to all of the intricacies here and all of the specifics, because the square root of this 5 does give you something else, and how everything kind of inflects and reflects on each other, and but we're going to keep things simple. We're not even messing with the square root of the second number. Don't have to worry about that right now. All right, let's hop to the back. Number 2. All right, everything looks normal. A minus sign, we got it equal to 1, which is what we want. And the y squared fraction comes first. So the curves are going to look like this. All right, so we can make our xy axis. Again, 2 normal asymptotes. Like such. Square root of 16 is 4. So these two are going to cross that positive negative 4 on the y-axis, because y fraction comes first. So positive 4, negative 4 are your 2 points of vertices. And then we can make our hyperbola with our 2 curves. All right. And one more, number 3. Sometimes the equation doesn't fit the bill right away and you have to move stuff around or divide through. We do have the minus sign, but it doesn't equal 1. So how do we get that 1? Right, we multiply through by 36. So we multiply by 36 here. And when you multiply the left side by 36, you basically just put 36 under each of these, because you divide each of these separately by 36. All right, so that will give us a 1 on the right. You can reduce this. 1, which you don't have to write. 4 over 36 is 1/9, so this will be y squared over 9. And this is 1/4. Don't have to write the 1, so this is x squared over 4. Now our equation looks like it should. X squared comes first, so this is going to cross the x-axis at the square root, which is going to be 2 and negative 2. All right, now we're ready to wrap things up by graphing number 3. So on the x-axis, 2 and negative 2. asymptotes. And we can make our two curves. And there we go, guys. That's how you graph a basic hyperbola centered at the origin for section 10.2, part 1. All right, thanks for listening, and I will see you guys in a couple of days.